All right, sounds great. And then just a couple quick reminders as we start diving in. Please keep yourself muted unless you have a question as we're going through the content today. And then if you haven't already renamed yourself from a login name to your actual name, that would be really helpful for us, just so that we can get to know you better as we're making our way through this course. And so, hi everyone, my name is Courtney Peterson and I am the Colorado NIACS member. So I'm actually based out of Colorado State University in Fort Collins, Colorado, and I work with Patricia and Kristen and Danielle at NIACS. I focus a lot on providing that climate adaptation information in the Southwest part of the US. And work with some of our partners with the Southwest Climate Hub. And then I also help coordinate an adaptive silviculture for climate change network under Dr. Linda Nagel at Colorado State University. And so thanks everyone for joining us again today and for being a part of our online adaptation planning and practices course. And so just a really brief agenda. We have a lot to cover today. We're not going to do so much of a discussion in this session. I think the content we're going to cover is going to take us pretty much to the top of the hour. But again, if you have questions as we're working our way through this content or any other references or resources about climate change impacts that you'd like to add, please feel free to put that into the chat box and we'll try to monitor that as we go along. And so we're going to really start diving into step 2 in this session of the Adaptation Planning and Practices course, which is really starting to think about that climate change impacts and vulnerability. And then of course, we'll wrap up with your assignment and homework for next week. And so last week, I think you all got to know each other a little bit and you talked about where you're coming from and your project locations. And so this is just a friendly reminder that a lot of us are focused in the Midwest or the Northeast. And then we also have some people who are west of the Mississippi and Utah and Nebraska. And so just be sure that you're connecting with your peers in this course. And if there's someone who has a similar ecosystem type or dealing with similar management challenges or the same insects and diseases, that it's a great way to connect with some of your other classmates and really think about what are some of those management considerations when we're dealing with climate change and trying to come up with some of those adaptation strategies. And so again, last week we completed step 1, which was really defining your management goals and objectives and your project location. And so this week we're going to be diving into step 2 and really thinking about assessing those climate change impacts and vulnerabilities for your area of interest. And so we'll be talking about some of the different assessment information and scientific literature and other resources that are available to us. And so one of the biggest challenges is to really translate some of this broad regional climate change information and into what this means specifically for our local project areas. And so when we're doing this in the first part of step 2, we want to really be thinking about how to evaluate some of those larger climate projections, such as temperature and precipitation and species range shifts, and then combining them with your expertise and your knowledge of your local site and the specific things that you value about the project area that you're working in, whether it's recreation or wildlife or aesthetics, to really think about how your site is going to be affected by climate change. And I'm sorry, they just started mowing outside, so if you hear that in the background, hopefully it's not too loud. So some of the big questions that we really want to focus on for this session are: how might your area be uniquely affected by climatic change and some of those subsequent impacts? And how might regional impacts be different for your project area? So really thinking about what are the characteristics of your specific location that are going to interact with climate change impacts that you're seeing on the ground. And so climate change is going to have a wide variety of effects on the landscape, and not all places are going to respond similarly. And so for this reason, it's really important for us to start thinking about what are some of those more general statewide and regional anticipated effects of a changing climate, but also how do we take some of those considerations to what it's specifically going to look like for our project area, and how might our location be uniquely affected? And so this step is really split up into two components. We want to look at some of those larger assessments of climate impacts that are drawn from the literature and current science, and then think about some of the unique site-specific considerations of how these impacts are going to impact the ecosystems that we care about. And so when you go into the adaptation workbook and mark your project location, it's going to preload your workbook with a number of regional impacts. And if you're located in one of the forested areas where NIACS has done a lot of our detailed vulnerability assessments in the Midwest and the Northeast, then you're going to get a ton of impacts in that list, and it's going to be pretty extensive. And so we're going to give you some tools and resources to start thinking about how to wade through some of those impacts that are presented in the adaptation workbook. And if you're not in one of the NIACS areas, you're still going to get a list of regional impacts that are drawn really heavily from the latest National Climate Assessment. And so, for example, you might see a general regional impact statement for your area that's talking about maybe the average increase in temperature or precipitation under both high and low scenarios. And so, for example, in your project area, you might be concerned about hemlock woolly adelgid and what warmer temperatures could mean for preventing some of that die-off during cooler temperatures. And so if you're in an area where hemlock is really important or really valuable on the landscape, or you're on that line where adelgid might be present but hasn't really started to impact hemlock yet, it might be something that you want to start thinking about more with climate change impacts and what those warmer temperatures mean for your project area. Another example is you might have a site that's really prone to flooding, or you've already seen a lot of damage from heavy precipitation events. And so if you expect more heavy precipitation in your region in the future, that might also be something that you want to consider that might end up being more problematic as we move forward under future climate scenarios. And so these are just ways that we want you to be thinking about stepping down some of those larger regional impacts that are based on some of those broad scale projections to some of those site-specific impacts based on your local knowledge and expertise and the management considerations that you're dealing with. And so this is just another written example of what this could look like within the adaptation workbook. So if you know of some of the regional impacts from vulnerability assessments, then you're again going to want to use your knowledge and expertise as the manager to really describe some of those specific site considerations. And so, for example, if you're in an upland forest and you know that some of the regional vulnerability assessments are saying that there's the increase for a potential summer drought, you might also realize that hilltops could be especially vulnerable to growing season moisture stress. And so that's something that you'd really want to consider and think about for your project area. And so what we're hoping you're going to do this week is really start to assemble information about your specific project area. And so we have some videos available for you to watch if you're located again in the Midwest or the Northeast, and you can find the links to those videos in the Getting Started guide. If you're not in one of those regions, please feel free to reach out to Patricia, Danielle, or I, and we can connect you with some of the additional resources to consider and to help you start thinking about climate change information that's more granular to your specific area. And so again, this week is really just a good time to start combining all of that information that you think will really be important as you're starting to consider some of those climate change challenges or opportunities. So again, start pulling together some of your tree species lists or inventories you might have for your area, or what is the stand or cover type maps. You might have some soil maps or watershed maps that could be helpful. You might also want to start thinking about topography if you're in an area with a large elevational gradient, or maybe you want to start thinking about some of the facilities such as roads or culverts or dams or those sorts of things, depending on the resource and your project area and what your goals and objectives really are for the area that you're managing. And so what we're going to do now is really start to go over a few of those resources that might be helpful for you as you're working your way through step 2 of the adaptation workbook. And so there's a wide variety of resources available, and not all of them are going to be specific to your project area. So you really, again, want to think about what are your goals and objectives and start to narrow in on the climate information that's specific to those goals and objectives in your location. And so one of the major resources available that's already integrated into the adaptation workbook are these NIACS regional vulnerability assessments. And so these documents were really created for natural resource professionals because they articulated a need for information that really talks about how tree species or ecosystems may respond to climate change. And so these assessments really embrace the uncertainty that we have to deal with when it comes to climate change by looking at the full range of climate future projections rather than just an ensemble that could overemphasize one potential climate pathway. And so we're really looking from those RCP 4.5 to those 8.5 climate scenarios of low and high emissions, and thinking about this across a spectrum of what these future climate change impacts are going to be. And so when we use these projections in combination with impact models and published studies and current research to look at the effects of ecosystems and then rate the vulnerability of major forest types within the regions located in the Midwest and the Northeast that NIACS works in. And so these assessments really help create that baseline of relevant information that we can then frame our response. But the key thing is that these assessments do not make management recommendations. They instead provide kind of an overview of this range of future climates so that you as the manager or the local expert can really take this information and come up with what you think is the best solution for climate adaptation strategies for the areas that you manage. We also have tree species habitat suitability handouts. And so these are for smaller areas and focus on a smaller scale than those more regional vulnerability assessments. And these can be divided by state boundaries or might focus on a specific ecoregion. And so these are just some of the tree species handouts that you could also consider as another resource when you're thinking about climate change impacts in step 2. And then a main source of the information provided in those species handouts is really the Climate Change Tree Atlas. And so this was developed by our colleagues at NIACS, Louis Iverson, Matt Peters, Anantha Prasad, and Steve Matthews, and that team. And the Tree Atlas really presents modeled changes in suitable habitat for 134 tree species and 147 bird species in the eastern US, anywhere to the east of the 100th meridian. And so it's really using forest inventory data and downscaled climate models to think about current and possible future distribution of those tree and bird species. And so just to walk through the Tree Atlas in a little bit more detail, the future projections of suitable habitat are again presented under a range of potential future scenarios. And so we have a low emission scenario, again that PCMB1 or RCP 4.5, which is really assuming that we might be able to reduce our emissions in the coming decades. And then there's the high emission scenario, so that's the RCP 8.5, which is kind of the continuing with business as usual scenario, continuing to create those emissions, and that's the most projected change. And so a few important things to keep in mind when using the Tree Atlas data. It operates at a pretty broad scale, so a 20-kilometer grid. And so the goal is not to look at specific pixel in space or a specific location, but really to use this information as more of a general regional indication of changes in suitable habitat for those tree or bird species. And so the Tree Atlas doesn't really account for microclimates or lake effect or urban heat islands. So those are things you have to consider as a manager on the ground. But what it does include is soils, precipitation, and topography, and some of those more ecological considerations when we're thinking about the changes in potential habitat suitability. And again, the Tree Atlas is based on that forest inventory and analysis data. And so we're looking at real observations of presence and abundance of different species, and then using that information to project future habitat suitability using those downscaled climate projections. And so here's an example using Honeylocust. And so on the left, we have mapped the current suitable habitat based on current habitat for Honeylocust. And then the red line is showing that Little's range for the Honeylocust species. And then the green and blue areas indicate where we have highly suitable habitat for Honeylocust. And then on the right side, we have the projected suitable habitat for the last 30 years of this century under both a low emissions and a high emissions scenario. And so what this is really projecting is an increase in suitable habitat of Honeylocust in areas like southern Minnesota, southern Wisconsin, northern Illinois, and Iowa, and then a loss of suitable habitat in places like Missouri and Kansas. And so this is just one example of a species included in the tree atlas and some of those maps that you can use as you're thinking about projected habitat suitability for different species in your area. And then if you're interested in a particular location, you can also search for the 1x1 degree area summaries surrounding your location and download an Excel file or a PDF file for your location. And so these are combined summaries for every 1x1 latitude and longitude area in the eastern US. And they really show lists of suitable habitat for species found within that 1x1 grid. And so when you download and read the summary, this is an example of what it's going to look like, and you can sort your list to find species that are likely to gain or lose that suitable habitat. And I know that these summaries can look kind of complicated at first, so if you have any questions, feel free to reach out to Danielle or Patricia or I, and we can help walk you through what some of these 1x1 summaries mean. But the key things we really want you to pay attention to are the habitat suitability change projections. And so those are that bracketed area with the change class 4.5 and the change class 8.5. So that's again showing that low and high emission scenarios and projected changes by the end of the century under those two scenarios. So where you see yellow or no change, that means that we don't see any changes in suitable habitat for those species in that particular 1x1 grid. If you see the green or a small or large increase, that means that there's an increase in suitable habitat for that species. And then vice versa, if there's the pink or small or large decrease, that means that there's a decrease in suitable habitat for that species under that 4.5 or 8.5 scenario in that 1x1 grid. And then the other things to look at are the FIA sum and FIA IV. And so those are those columns directly to the left of those change projections. And so IV stands for importance value, and it's just letting you know how abundant that species currently is. And so again, these Excel summaries are organized or sorted by most common to least common species. And if you have any questions, don't hesitate to reach out to us. And then if you're curious what climate impacts are provided to you based on your project area, you can also take a peek at the NIACS Impacts Explorer tool in the Adaptation Workbook, and this is on the Adaptation Workbook website. And so we've summarized climate change projections from regional forest ecosystem vulnerability assessments and the National Climate Assessment for all 50 states. And so this information is already integrated into your workbook for your location, depending on where you placed your pin for your project area. And so it'll preload a lot of the information from this Impacts Explorer into your adaptation workbook that you can start sifting through and really thinking about depending on your management goals and objectives. And so this is what it'll look like in the adaptation workbook. Again, depending on where your pin is in your region, it'll preload a bunch of this climate vulnerability assessment information, and then you can scroll through and start to look at what some of the citations or assessments or information is for your location and start to dig into some of those links and tools and resources to see where it's coming from using this Explore Impacts tool. And so there's a few more resources that we just want to briefly cover. So you don't need to limit yourself to the NIACS vulnerability assessments and the information that we have available. There's a ton of other excellent resources that you can use that might be more specific for your geography or your particular management topic. So one example is the NOAA state summaries, and they provide a great overview of what to expect for your state. giving information on climate trends and projections for all 50 states, and you can download a PDF summary or view that information online using that statesummaries.ncics.org link. There's also regional assessments through the USDA climate hubs. And so NIACS serves as the Northern Forest Climate Hub, but there's other hubs that focus on different sectors of the US. And so for folks who are in Utah or Nebraska, you might also want to dig into some of these climate hub assessments for your area as well, and see some of the vulnerability assessments that are featured for your region. And then don't forget to dive into your own networks or to think about some of the tools that may be available for your specific state. And so all of the states are going through their state forest action plan updates. There might be some good climate change information available there that you might want to pull from, or there might be other networks or organizations such as the Wisconsin Initiative on Climate Change Impacts that are also great resources and tools for you to be pulling some of that specific climate change impact information from for your project areas. And then our tools focus a lot on the Midwest and the Northeast, but because that's the footprint that for the most part we work in. However, in the West, there's a group called Adaptation Partners that we also work closely with, and they have some great regional and state information and have done a ton of vulnerability assessments for national forests and national parks in the Intermountain West and the Pacific Northwest and the Pacific Southwest. So these are just some other examples of tools that you can be thinking about. But again, don't hesitate to contact us directly if you need more ideas for some of those regionally appropriate resources for your area. And then just a quick pitch for some other tools in addition to the Atlas that might be useful for your project or some of the types of resources you're thinking about on your landscape. There's some tools out there for fish habitat or water temperature. And so one example in the West is the Norwest tool from the Rocky Mountain Research Station, which really looks at stream temperature projections. Or another example is FishViz for the Midwest and the Northeast. And so that's showing potential climate-driven responses for 13 different fish species and streams across the Great Lakes region. And so these are just some other examples of different tools that are out there, depending on the resource that you're focusing on and the type of ecosystem or some of those values that you really care about for your project area that you want to know more about specific climate change impacts. And so again, feel free to reach out to us if you have questions or need more information or have a specific value that you're looking at and need to be pointed in the direction to find some of those climate change impacts. And so with that, I'm gonna stop sharing and pass it off to Patricia.
All right. Hi, everybody.
Hey, Patricia.
Getting my screen set up here. Okay, so just to recap, the climate change tree atlas modeled 134 tree species in the eastern
Patricia.
U.S., so not the western U.S.
Patricia,
so
we can't see your
eastern
screen.
U.S., those trees.
We can't see your PowerPoint screen.
I'm sorry, Danielle?
There you go. I don't know if your connection was slower, but it took a while to see your screen. So,
did you say something? Yeah.
I think okay. I think your connection is a little bit slower, but are you in presentation mode right now?
Okay. I think that's what might be going on because there's a significant lag between our conversation as well.
Yes. Okay. I see your slides. We're good. Ooh. Uh-oh.
It looks like we lost her.
Okay. Well, I can get the slides up, and then if she comes back, we can hand it back. How about that? Unless you're ready, Courtney. Let's see.
Go for it, Danielle.
Okay. It's all about adaptation, right, folks? I haven't practiced these slides, so we're just gonna go. Okay, so real world.
Danielle,
What
can
if
you
you are
hear me? I'm back.
You're back. Okay.
Yes, I'm gonna stop sharing my video and see if that helps, okay?
Okay.
We'll give
already
this one
sounds better.
more shot.
Your audio sounds a lot better, so it sounds like that might have helped the connection.
Okay. Now, can you see my slide again?
Not in presentation mode, just seeing the. There you go. There's I do have the chat box or the attendance box up on
Okay,
your
so
screen.
there's still a little bit of a lag. Well, no.
Okay,
Wait,
there's
yes.
like a black
Yes,
box
I do.
there. Okay.
Is that better? Okay.
Yes.
All right, we'll give this one more shot, and then you'll have to take over if I lose my connection again.
Okay.
The tragedies of having to work from home, right? Okay, so just to recap, the Climate Change Tree Atlas modeled 134 tree species in the eastern U.S., so not the western U.S. And in the eastern U.S., those tree species occurred in enough abundance to be detected by the forest inventory data, meaning that rare species often did not get modeled. So what can you use when you're interested in those less abundant species that might include shrubs, cultivars, or even non-native species that are relevant to your project area? And the answer is heat and hardiness zones. So I'm sure many of you know that the USDA has divided the country into regions based on average low winter temperatures called plant hardiness zones. We use this for gardening all of the time. Plants are assigned to hardiness zones based on the lowest temperature that the plant can tolerate before cellular damage occurs. Winter temperatures have been rising dramatically across much of the country, and this trend is expected to continue into the future. For example, minimum winter temperature could rise at least 8 to 9 degrees Celsius across much of the Northeast and Midwest, the range of 14 to 16 degrees Fahrenheit. So winter temperatures have been warming faster than any other season and will continue to do so. The Forest Service has used these projections, and this is the same team that Courtney told us about, the Landscape Change Research Group led by Lewis Iverson and Matt Peters and others in the Northern Research Station. They've used these future projections of temperature and precipitation in order to create maps of future projected heat and hardiness zones for the entire conterminous US. And if you go to this link, the HTTPS link at the bottom here, you can actually look at a story map that provides a slider tool and really zoom in on your region of interest. Or if you want to view other time periods or other greenhouse gas emissions scenarios, there is a link to the underlying maps on the story maps, and you can visit them with this link here. Then you can go to the Contents tab and select whatever period and scenario you want to be looking at. You can also download these maps to your desktop GIS by clicking on the Information tab and then click on More Details and then open in ArcGIS. Okay. So let's walk through how we might use this information to look at rare or cultivar tree or shrub species. So we'll use this information using the Black Hills spruce as an example. The Black Hills spruce is a variety of white spruce that is native to the Black Hills region of South Dakota and adjacent Wyoming, and is therefore completely outside the range of the climate change tree atlas. So how we assess this species is we would first look up the published heat and hardiness zone tolerance ranges for the species on the web or in a book. For this species, the published zone range is from 2 to 8 for hardiness zones. And the Black Hills are currently supporting classes zones 4 and 5.
She was on a roll. Katie, I sent Patricia that message before she left, so hopefully she'll try that. Katie had an idea that maybe just using Zoom on your computer, but calling in using your phone and connecting might encourage even more bandwidth.
Yeah,
okay.
I was having this very same issue with my committees, and one of my committee members taught me this trick, and
Cool.
I really needed it.
Oh man, the things we're learning, right? I was sharing with Katie that we try not to use the telephone because of the audio. It's just not as crisp, but hey, if it helps us have the presentation, then we'll take what we can get. You're back, Patricia. Oh, maybe she's calling in. Or she's on mute.
Hey, so where did I leave off on this slide? It's complicated.
Well, you were talking about, for this species, the published hardiness zone. I think you're at the top of the flowchart.
Okay, we're at the top of the flowchart. So, okay, so we'll back up here. So first, what we have to do for the Black Hills spruce is look up its published heat zone and hardiness zone tolerances. So we can look for these on the web or in other publications and see that this species tolerates hardiness zones that range from 2 to 8, and it tolerates heat zones that range from 1 to 7. And then next, we look up the current and future projected zones using the climate change, the heat zone and hardiness zone projections from the LCRG. So for this species, the hardiness zone in the Black Hills region supports zones 6 through 8. And the projected heat zone tolerance at the end of the century, it supports 7 to 8. And so we lose one heat zone, but it's still, let me back up. I'm confusing myself. Sorry for the technical difficulties today. Okay, so first we look up the published heat and hardiness zone tolerances for the species. That's number 1. I've covered that clearly. So next we look up the projected hardiness zone ranges. Let's just focus on that. So at the end of the century, South Dakota and Wyoming are now in zones 6 to 8, which is a shift toward warmer conditions, but still within the hardiness tolerance of the species. Next, heat zones represent the potential heat stress for plants and animals based on the number of days per year with a maximum daily temperature greater than 86 degrees. So that's looking at the heat stress for individual plants. So if we follow the same process for the heat zones, we can see that the species can tolerate zones 1 through 7, with the Black Hills currently providing zones 1 to 5 or up to 45 days per year over 86 degrees. And we can see on the map that this area here that represents the Black Hills is higher in elevation, which makes this area quite different from lower elevation areas. And when we compare its published tolerance ranges to the projected ranges at the end of the century, the Black Hills region is projected to have zero. So the species loses one full heat zone range, create heat stress for the species. So hopefully you can see where it might be useful to compare both the hardiness zone with minimum temperatures and the heat zones with those higher, warmer heat stress temperatures for any given species. And one thing I noticed while doing this exercise was that the heat and hardiness zones, the heat zone, then classifying those days into heat zones. So if you click on the link under the heat zone range right here, then you can see the same classification for your species and be able to lump those changes in days over 86 degrees to the published heat zones. And again, if you need help doing that or don't understand what that means, just let us know and I can definitely walk you through that. Urban forests often have a high number of non-native species and cultivars, and this process is particularly useful for cities. And the most comprehensive list of tree species we have so far can be found for Chicago, but we also have additional information for Boston, Cleveland, Detroit, Philadelphia, New York City, and the Twin Cities. And Pennsylvania also created a list for common riparian species that were not modeled by the Climate Change Tree Atlas. So you can contact me for more information about Pennsylvania, or I can hook you up with Leslie Brandt, who can provide more information on those urban areas. Now, it's very tempting to start connecting the dots and thinking about how climate change will affect your daily work. But for step number 2, we will discourage you from jumping ahead quite yet. For now, we just want you to focus on how climate change will affect the biological components and ecosystem processes at the project location. So here we want you to really think about, as Courtney already mentioned, the hydrology, the soils, the vegetation, and other relevant components, maybe even the wildlife or the connectivity of your site. Then in step number 3, our next step, we will explore how this creates challenges and opportunities for your management or your daily activities. So really just focus on your ecosystem for now. So now I'm going to introduce step 2.2 in the adaptation workbook. After you identify your climate change impacts that will affect your project area, you will need to assess the vulnerability of your forest types and your management topics to climate change. So vulnerability. Vulnerability is the degree to which a system is susceptible to and unable to cope with adverse effects of climate change, including climate variability and extremes. In other words, are climate change impacts going to cause substantial disruption to a particular system? And there are 2 components to vulnerability. The first is taking into account the potential impacts, and the second is taking into account adaptive capacity. The graphic shown here will help determine vulnerability, or it will help us modify vulnerability for predefined in the adaptation workbook. And you can select various likely benefiting the system to disrupting the system. And you can also define the adaptive capacity from low to high. So let's take a look at what each of these mean. The potential impacts of climate change can be thought of as a combination of the exposure to changes as well as the sensitivity of the system to those changes. So if we use the Black Hills as an example, we'd consider the region and take into account the varying elevation in the Black Hills, the microclimates that variation creates, and then the different soil types and species. And then we think about how sensitive the system is to those changes. The Black Hills spruce we saw may be able to tolerate projected warming temperatures at the high higher elevations, but may face increased heat stress at the lower elevations, potentially shrinking acceptable range for that species. Another example that might resonate with you is if an area covering the same elevation is exposed fully to 3 degrees Fahrenheit warming. The stand of oak trees in that region will likely be less sensitive to that warming than cold-loving spruce trees, which might have a harder time dealing with that increase in temperature. So that's impacts. And next we think about the adaptive capacity of the system, which is the system's inherent ability to tolerate projected climate change impacts. And this is different from sensitivity because here we're looking for those qualities that might help a system in those impacts. Again, using the Black Hills example, we might consider areas at higher elevation or areas that retain cold air pockets and microclimates. We might consider those areas to have higher adaptive capacity than, again, those areas at lower elevations. And ideally, you'd consider adaptive capacity of all your dominant species. In another example, we might identify higher adaptive capacity in a forest that contains a variety of species compared to a forest with only 1 or 2 dominant species. And the reason for this is that species can vary in their adaptive capacity. In the tree atlas and urban vulnerability lists, you'll find an adaptability score or rating already provided for you. And these are based on biological factors. In general, if your system is on the higher end of the spectrum, it might be more tolerant to drought, heat, or herbivory. It might also be good at seed dispersal or tolerate a wide range of soil conditions. And these characteristics would make it more likely that the species could persist or even shift on the landscape as conditions change. If a species is on the low end of the spectrum, it likely has low adaptive capacity and might not fare well under a changing climate. Examples of adaptive capacity factors in ecosystems can include characteristics related to species diversity, connectivity, age class diversity, and also genetic diversity. So thinking in these different bins can really help identify examples of adaptive capacity. Hydrology is another important factor. Some of the things to consider would be whether the system is groundwater fed or if it must rely on precipitation for all of its needs. We can also think about the net flow of water into and out of a system. Some soils may be able to absorb water and hold it for some length of time, while other soils might be thin over bedrock and allow more water to run off. Or there may be impervious surfaces like parking lots or other infrastructure that impact the flow of water at your site. Whether you're located at the headwaters or downstream can be important, especially if there are detriments to being downstream, such as receiving agricultural runoff or the seeds from invasive species. And in urban environments, adaptive capacity is even more complex and is based on several additional themes which take into account social and economic factors. For organizational factors, there might be plans or policies that really dictate a site. In economic, the ability to get grants or function within city budgets might impact management of urban forests. And under the social category, we might rely very much on a volunteer base or protection from the community. So coming back around to vulnerability, then we can rate the vulnerability of a system by both the potential impacts and the adaptive capacity. As you're filling out the online adaptation workbook, you'll be able to rate the vulnerability of each of your forest types or management topics by simply moving the slider around. Potential impacts are evaluated on a scale of, and we want you to consider all of your impacts together and whether you have mostly negative impacts or maybe a mix of negative and positive impacts, or predominantly positive impacts. And then adaptive capacity is evaluated from low adaptive capacity and high adaptive capacity. And again, we want you to think about the adaptive capacity of your system overall. And then based on your ratings of potential impacts and adaptive capacity, a vulnerability determination will be generated for you. And this rating varies from high to moderate to low and is calculated similarly to this figure where impacts are on the x-axis and adaptive capacity is on the y-axis. And if you're using a paper version of the workbook, then you'll use this chart to assess your vulnerability. You may have noticed that forest types were preloaded into the adaptation workbook, and if you're within a region for which a vulnerability assessment was published, you'll see those forest types get preloaded into your workbook. These forest types were drawn from the New England Vulnerability Assessment, the ones I'm showing you here. But each assessment in this suite uses an expert elicitation process to evaluate the potential impacts, the adaptive capacity, and then they finally assign that rating of vulnerability as well as a level of evidence and confidence for each forest system. So the expert panelists for New England evaluated vulnerability across the entire New England region. But because forest systems vary widely at a local level due to those differences in elevation, climate, landform, etc., the vulnerability in your particular location might be slightly different from the broad vulnerability determination given here. So again, these should act as a starting point for considering ecosystem vulnerability, but you should still use your own judgment and expertise. So let's quickly take a look at one of these forest types, the central hardwoods. We have moderate to positive impacts, and we have moderate to high adaptive capacity, which gives us a rating of low vulnerability. And then we can use the vulnerability assessments to dig into the forest system descriptions and potential drivers so we know what that actually means. For this system, the impacts are described in that the system is at the northern range, the northern extent of its range in the region. It occurs on a wide variety of dry to mesic sites and coarse, well-drained soils. And the many tree species found in this forest type include lots of oaks, including black chestnut, scarlet, and white oak, and also hickories, pignut, and shagbark hickory, which are generally expected to be able to persist on these sites into the future. And these species may also potentially expand to new areas as conditions become suitable. But insect pests such as winter moth and southern pine beetle. And then under adaptive capacity, the factors that were really important in this system were that the system can tolerate and even thrive under warmer and drier conditions, with many of the species being able to regenerate well in diverse soil conditions. And this system is also
Okay, well, unfortunately, let's see what screen I was just sharing. Unfortunately, Patricia was like 1 second away from saying, and now I'm going to give it to Danielle. So we'll just go, and then when she comes back on, then we can finish it up. But what she was getting at essentially is that although you're sort of spoon-fed when you drop your pin within the Midwest or the Northeast, you might be spoon-fed some vulnerability information about a particular forest type. And what we want you to do is sort of feel free to dig into that to uncover what those vulnerability determinations mean and why, because some of you actually participated in the expert elicitation process. We brought people together, they asked a lot of questions, and so these are not bias ratings, these are based on sort of a group consensus. So definitely dig into them. All of the vulnerability information, the statements are cited, so you can find the resources really quickly. Okay. So I'm going to go into the last section, which is just really brief. I actually got a few emails during this call, during this session right now, about the information we were just covering. So I'm glad that we prepared this recap. All of the slides will be given to you after this call as well. But as we were going through the slide deck, we're like, man, this is so much information. Let's do a quick recap just to make sure that all of you are sort of on the same page before we end this session. So going back, is my tree vulnerable to climate change? How do I figure that out? Through a few examples. Okay, so if you are located where I'm located, way up in the Upper Peninsula, you might be thinking about a tree like Eastern Hemlock. Well, according to the location on the map, you actually fall right within one of our vulnerability assessment areas. So sort of the logical thinking for you would be finding the climate change resource option that's available to you, which is the vulnerability assessment. We call it the EVAS, the Ecosystem Vulnerability Assessment and Synthesis. And you also have the tree atlas because you're on the eastern side of the Mississippi. So as far as number one goes, there's a lot of information that's available to you, and I'll remind you what those sources are. You can dig into those resources to learn about the tree characteristics that Patricia was referring to and really start to better understand broadly how this tree might be affected by climate change, and then start to translate that into, this number 3 bullet, step 2 information, which is what does that mean for my site, given all of the landform that I'm operating on, given where I'm situated in my watershed, given the stressors that are unique to my area, does that projection make sense? And then we would hope you would get to number 4, which is using all of that information to make a climate-informed decision about the vulnerability of your tree or your wildlife habitat, whatever it is, in your adaptation plan. So this is the straightest logical 1, 2, 3, 4 step. Now, like I said, the green areas on this map are the areas where we have those ecosystem vulnerability assessments, those in-depth resources that talk about tree species and habitat projections into the future. So you can find about 80 common species to these areas. If you have a rare cultivar shrub species, then you're going to have to think about a different way to establish its climate vulnerability. But if you are, this is where you would go, and you can go to, it's already spoon-fed for you based on where you dropped your pin, but you can go and browse for any region, any of the vulnerability assessment information at adaptationworkbook.org/explore impacts. And for the other states, we have just basic climate information provided by the National Climate Assessment. Okay, and so just a reminder, when you click on one of the green places on the map, you'll see this pop up that will help you dive into the specifics related to whatever that tree type is that you care about. And here I put white pine just to show you, all of the citations that are relevant and present within these impact statements. Okay, so moving into the next realm, if you have a tree that is vulnerable to climate change, but you know, is rare or not present in your area, something maybe like loblolly pine, something that is you know, a pine that might be native to the southeastern US. Loblolly pine is actually mostly found in central Texas all the way to Florida, but can be found all the way to Delaware and southern New Jersey, which I actually didn't know when I was looking up this information. So some of you might actually be interested in a very southern species, and it just isn't going to be spoon-fed to you when you drop your pin in the adaptation workbook. We know that loblolly pine can be expected to grow in hardiness zones 6 through 9. So, you know, what information can I use to help assess if this species will grow in my location? So, you know, let's pretend me in the Upper Peninsula, I'm thinking about loblolly pine. Well, I cannot use the EVAS, the Ecosystem Vulnerability Assessment, because loblolly pine wasn't included. So I need to go right to the Forest Service Tree Atlas website, which Courtney described, and you guys can have access to that presentation to review. This is where I can go to begin understanding not only its life history characteristics, and but also start to explore the potential climate change projections and adaptability for the species. You know, what is its possible habitat range given future climate changes? The Tree Atlas provides hints as to potential positive and negative tree species traits that could increase or decrease its chance of survival. So you go all the way over in those boxes on the right-hand screen and start clicking them and expanding them. And you'll get to one, climate change adaptability, that looks like this. And this is where you can really start to uncover those positive traits that might allow it to expand its range, in addition to its negative traits, things that might hinder its growth in range. So you'll have to go right to the source. This kind of information isn't going to be provided within the adaptation workbook, but that's okay. You can use all this information that you have uncovered to start thinking about what this means for the tree species at your site, incorporating in those local characteristics such as terrain and landform and hydrology to better uncover its adaptive capacity at that site. And again, you'll get to step to that fourth idea, which is to use this data to make a climate-informed decision in your planning. Okay, so now, if you care about a rare cultivar or a tree species that is not only not included in the ecosystem assessments that NIACS offers or the Tree Atlas, you'll have to do a little bit more work on your own. So in this example, I'm showing Allegheny serviceberry, which can be found in some urban areas and might just be very unique to your area. This species is not modeled in the assessments or the Tree Atlas. So, you know, unfortunately, you're going to have to do even more digging. And we covered the basic methodology for what you would do next in this lecture. So, you know, recall this might mean hunting down species-specific information, such as heat and hardiness zone information, that you can then use to compare and decide if the growing conditions of that tree will be vulnerable to changes in growing degree days or changes in hardiness and heat zones. Patricia covered a great example to walk us through that. So this is where, unfortunately, the work really does fall on you. You're going to have to do the legwork to understand those potential issues. You know, we would ask that you would find reputable sources that will describe trees characteristics. You know, look for Forest Service, University Extension, or Arboretum web pages or books, and then cite them within your plan. So when you within the adaptation workbook, you have the option to add your own climate impacts, and then you would have to add your own citation as well. I'm giving you in this sub-bullet 2 and 3 some examples of great websites that I like to go to find heat and hardiness zone information. One which is great for trees from Florida, and another one that's great for plants from the Morton Arboretum outside of Chicago. So you would take all of that information and compare those growing conditions to those future projected changes in heat and hardiness zones. And then you'd get to the step 2 questions of, you know, what does this mean for my plant, what habitat at the location that I care about? And then you would hopefully use that information to make a climate-informed decision in your planning. So just a reminder of how to find those future heat and hardiness and growing degree day projections for your area. You would go to the link of the tool that we talked about in this session. You zoom into your area, check out the legend so that you can start comparing those current conditions, which is shown on the left-hand side of the slider here, and the high emission scenario. So you can see where I'm located, I'm looking at some sort of change between a 5 to a 7 zonal change by end of century. And again, you can download this information and incorporate it in your GIS today. All right, and lastly, what if you have an ecosystem? So we've been talking about individual trees or shrubs or even species. You know, if they have some climate information that we could point you to related to a wildlife species or a fish species. But what about an ecosystem? You know, similar to the last example, this is an example of a boreal rich fen. So if you're in Wisconsin, you know that we have lots of wetlands that we care about, and we sometimes do think of them holistically, similar to how we think about a forest type. So in this example, you will have to do a lot of digging because this information is not readily available, but it does exist. So here I'm highlighting where you can find some of that information in Wisconsin, but definitely does apply to other areas in the Midwest and Northeast. And I would suggest going and checking out the wiki plants and natural, the Wisconsin Initiative for Climate Change Impacts. There's a subgroup called the Plants and Natural Resources working group that has created these really cool climate change vulnerability assessments for different natural communities. And so you can really dig in and start looking at the, you know, the viability of your alder thicket, which I'm guessing it's not going to be that vulnerable to changes in climate. It's probably going to love it. Or you know, other things like interdunal wetlands, mesic prairies, moist cliffs, and all of these climate change assessments took on the same expert elicitation process as our NIACS forest assessments. They were modeled using the same methodology. And they're great. They provide a really good starting place for you to start understanding what are those little buttons and levers that might significantly change this community type if the climate trajectory goes one way or the other. It can just help provide that baseline thinking for you. So again, you would take this information, incorporate it into your online adaptation plan, and cite one of these web links and use it to help provide that foundation for you to then dial it down to your site, figure out what it means for the place that you care about, and use that data to make a climate-informed decision in planning. So those are examples of tree information, rare or other trees or shrubs or woody vegetation, or maybe even perennial, and also an ecosystem example. And hopefully all of this information is you feel like is accessible to you to use in your plan today. So that is the end. Before we get to questions, I guess, we'll just give you this, run through these really quick and then let you go. Some quick tips on how to use the adaptation workbook in step 2. Like we've been talking about, you might be presented with very specific climate change information that was filtered for you when you dropped your pin on the map. You know, let us know if you're not getting any information or, you know, whatever, we'll help to troubleshoot that. You can accept all of the climate impacts that are prepared for you, or you can just remove a ton of them and say, hey, I'm only here to think about these top 3 impacts because they're going to have the biggest effect on my landscape. Go ahead and remove them. All you have to do is click that little X and it will bring it over to another side. You can always bring it back if you'd like. You can use this step and this week as an opportunity to really dig in and get specific to describe how climate change impacts will affect your project area. What will that effect be? Is it increased flooding? Is it increased water levels? Is it you know, prolonged drought? What is the effect that that's going to have on that landform? Again, you can add your own custom impact, have those citations handy. And, you know, we have given you vulnerability determinations for certain forest types, but they're adjustable. So you can make that determination on your own. If you want to see screenshots of how all of this works, you can find a link to the Adaptation Workbook Cookbook, a little tutorial, and watch recorded tutorials that are embedded within each step. Your assignment for next time, really start, you know, taking hold of this climate change information and vulnerability and get comfortable with it and really start to digest it. Use this week to do that. Contact us if you have questions or you're looking for something topically or regionally appropriate for the question that you're trying to answer. And watch some of the video presentations that we've included in the Getting Started guide, which will give you more of a regional focused look at climate projections for your area. So complete all your work before next session, which will be next Tuesday, June 30th. And we'll be moving into starting to evaluate how climate change will affect our goals and our objectives and the things that we're trying to do on the landscape. We will reach out to all of you to schedule a check-in meeting with one of us, and we'll just have a little side conversation with you next week to just get a handle on, you know, your project, learn a little bit more about how you're thinking about climate change effects in that project. Okay, and that is all I have for today. Thanks for staying a little bit later.